All right, exam 3, sample 3, coming up. Sorry, I had to erase some of this and do it again. Identify the local max and min of this function. So now I need to take the first derivative. 5x to the 4th minus 45x squared. All right, set that equal to 0. I can factor this out. X squared, I have an x squared minus 9 left. Guess what that is? X minus 3, x plus 3. So our x's are 0, 3, and negative 3. Okay? I want to check what's going on at those. So I'm going to see what the first derivative is doing. Not at these points, right? These are our zeros. Alright, if I test 1 and I test negative 1, guess what? I'm getting the same answer because these things are squared. So these are all negatives. If I come out here and test 4, I get positives, and down here I get positives. So that means we have a max at x equals negative 3. The critical point x equals 0 is neither, because we're still all negative, and we have x equals 3 is a minimum because we have a negative slope to a positive slope. Here we have a positive slope to a negative slope. All right, to find the points of inflection, we want to take the second derivative, which is going to be 20x to the 3rd minus 90x. Sounds right. Equals 0. Notice I can factor out 10x, and I have 2x squared minus 9. So here x equals 0, and 2x squared equals 9. X squared equals 9 over 2. If I take the square root, okay, so x equals 3 over the square root of 2, plus and minus, which if I rationalize, points of inflection are at 3 square root of 2 over 2, as well as 0. So I have 3 points of inflection, okay? Now, what I'm trying to decide, what I did too, was I graphed the original function. And I went to see if these things make sense. What I got for this and what I got for these points of inflection. So these are the points of inflection. And I think that's answering everything I was looking for. I didn't have to test. I guess I could see. I would say at if I go negative 3 square root of 2 over 2, that's about negative 2.12. So that means here, where this thing is going down, yeah, so we have a point of inflection in here, here, and here. They didn't ask us what's going on with the concave up or concave down, so I guess I won't really worry about it, but let's see what's next. Consider this function. If it has a critical point here, what do we know? Well, let's talk about what they gave us here. If it's a critical point, that means the first derivative at 2 equals 0. And because this is a point on the graph, the original function at 2 has to equal 5. They've given us 2 pieces of information. So let's take the first derivative of this. It equals 4x to the 3rd minus 4ax, doesn't it? So if this equals 0 when x is 2, I'm going to come in here and say 2 to the 3rd minus 4a times 2 equals 0. So 2 to the 3rd is 8 times 4 is 32 minus 8a equals 0. 32 equals 8a. A equals 32 over 8, which equals 4. So I got 8 equals 4, right? Now, the original function at 2 equals 5. So the original function looks like this. Plug in 2.